Professor Von Decibel, and that was a sound. These are sounds coming from my mouth presently. All around us all the time are sounds. There's probably sounds in your classrooms right now. Someone's probably sneezing and coughing and the like. Now, with the help of my assistants here, Marion and Lillian. Smile, Lillian. We are going to explain to you about the wonderful worlds of sounds. Now, please come back this way, please, Mr. Cameraman. These are all the things that have to do with sounds that we are going to teach you about. You have compression, and refraction, and pitch, and Doppler, and intensity, and decibel, and etc. All of which are listed here. We're going to go show you those things now.
I wonder what these do.
What are you ladies doing?
We don't know what this means.
You obviously don't know anything about compression and refraction. Let me explain. Hello, children. I'm going to explain to you about the production of sound waves, utilizing the terms compression and refraction. Now, all production of sound waves starts with a vibrating object, such as a guitar string, and the vibrating of an engine, and your vocal cords, for example. Now, with the help of my assistant, Marion, and a tuning fork, we're going to show you. Marion, if you would strike the tuning fork. Very good. You're getting a cookie later. Notice, well, you can't really see because it's really far away, notice how the tuning fork vibrates back and forth. When the tuning fork prongs vibrate to that direction, which is your left, high molecular density happens and high air pressure. When it vibrates back to this direction, which is my right, you get areas of low molecular density and low air pressure. Now, as they swing back and forth, the air molecules move with simple harmonic motion, just as the prongs move with simple harmonic motion. That is what creates sound. Sound is determined, pitch is how we perceive sounds to our ears. So you could have a low pitch. Hey! And a high pitch. Pitch is determined by frequency, as well as background noise and loudness of the sound. And that, children, is sound waves. Did you guys get that stuff I wanted for the cookies?
Yeah, we did, but why are you yelling?
What?
Why are you yelling? Nobody's yelling here.
Because my intensity's high, man!
Well, what's that?
Let me explain. Intensity is the rate of energy flow through a given area, where P equals power and area obviously equals area. Now, power is measured in watts, and area is generally measured in meters squared. So it goes to follow that intensity will be measured in watts per meter squared. Now, intensity is also measured in decibels. A higher intensity equals a higher decibel rating. A lower intensity equals obviously a lower decibel rating. Also, decibels can be so loud that they can hurt and damage your ears. The threshold of pain for damage that can cause you to not hear well anymore is 120 decibels. So if you're around, you know, a jet engine, it's a good idea to wear earplugs. Also, intensity and frequency determine audible sounds. So if you have a low intensity and a low frequency, you're not going to hear very much. And a very high frequency with a very high intensity, you're not going to hear very much then either. You're probably going to die.
So, Professor, what'd you do to your hair?
I don't want to talk about it.
I wonder where the professor went.
You okay? Well, I noticed from when you were over there, your sound changed. What does that mean?
Let me explain. Children, I'm once again going to teach you about something that you need to know about. Have you ever been on the street and an ice cream truck passed and you noticed that between the time you were behind it and when you were in front of it, the sound changed? That's called the Doppler effect. Now, we will consider, for example, an object that moves and produces a constant sound. We'll call it the LO for moving object. And there's an observer behind it and an observer in front of it. Now, because the object is moving in that direction, the sound waves are closer knit
In front of.
than in
Behind.
obviously. Now, because the sound waves hit observer A, who is in front, more often, the frequency perceived by him is greater. And because they hit him less, observer B, because he's behind, the frequency is lower. We learned before, when I taught you, it's very important that you listen to me, that frequency determines pitch. So, Doppler effect obviously influences pitch. And that, children, is Doppler effect.